Well, Joy, in this video, I'm going to show you how to create your first part in Solid Edge. I've loaded up Solid Edge, and all I'm going to do is I'm going to click the New button, and we have different options here. I can select from the list here, or I can open a dialog to select from a list of templates available on Solid Edge. You can also create your own templates. For this, we're making a part. So for most people, ISO metric part will work fine. I select that. If you're in the US, you could select ANSI inch and choose out of the templates here. There's also ANSI metric, but yeah, so we have ISO metric. I'm just going to click on that and click OK. And by default, Solid Edge will show you here that ordered is set as default. There's also the synchronous environment, but for this video, we're just going to stick with ordered. So I'm going to click continue with ordered. And now we have the Solid Edge interface open. We're in the ordered environment here, so everything's okay. All you can see really is the coordinate system showing. And we have this cube here called the view cube with the name of each of the views. At the moment, we're kind of looking almost at the front view at a little bit of an angle. If I click on the front face of the view cube, we're now looking at the front view. I can click on these arrows to rotate around to the left view, around again to the back, and around to the right, and around again to the front view. And we can go up, look at the top view. We can also click at the corners to look at a kind of isometric kind of view. We can also rotate the view. So if I want the Z-axis facing up, I can click on this arrow here to rotate it up. We can also turn off our base view here. That little picture of the eyeball here shows what's showing and what's hidden, so I can hide my base view. I can also show it, and I can show my base reference planes. Okay, so I'm just zooming in here, and I'm just going to click the home, and for our first part we're going to want to do a basic extrude. So I click on this command here. Something actually, I'm just going to cancel out of that. And something that's actually really helpful in Solid Edge, you can hover over a command and it will show a little animation of how it works, which is a really nice refresher if you're stuck. And there's also the F1 key for help. Also, you can type here to search for different commands, and if you're familiar with another CAD package and you know the command name in that CAD package, you can try typing it into this box and it might show you something here as well. It's very good for SolidWorks commands, and I'm sure other commands too, to find similar command in Solid Edge. Right, so we want to extrude, so I'm going to click extrude, and we're kind of going through a process, a workflow here. So first of all, it's asking for a sketch, create from coincident plane. So there are other options, but this is the default, so coincident plane. And for me, the logical way to create this is on the top plane. What I can do is I know this is the top plane just by coordinating the views, or to be sure, I can click on this. And now actually I can't see the top plane properly because I'm looking directly at it, but I can click on it here on the Pathfinder. Now that we have selected what plane we want our sketch to be drawn on, Solid Edge has brought us into the sketch environment, which you can see by Solid Edge now displaying sketch on the title bar and the change in commands available to us. Solid Edge has automatically selected the line command for us, but we don't want to draw a line, so you can select the circle command instead. I can just click, and if I move my mouse around, the size of the circle changes. Because I know exactly what size circle I want, I can just type in on my keyboard 25.75 and press enter. And now Solid Edge stays in the circle command. And if I click again, I can create another circle of the same diameter, and again and again. But because we don't actually want that, so I'm going to click undo, undo, undo. And now I'm just going to go back and click circle again. And this time I'm going to click the center of the circle. I'm just hovering over this here, which is actually a plane. So this is the ZY plane. So if I click the center of the circle there and now drag out the circle, and this time I'm not going to choose any particular diameter. I'm just going to click anything. Now let's take a look at these two circles. The first one, when I click on it, you can see the diameter 25.75, which is what we wanted. If I click on the center, I can drag it around anywhere I want. Let go. And then for this one down here, if I click on the circle, we can see the diameter is currently 31.3 millimeters. And if I click on the circle, I can drag it up and down. But when I try to drag it left and right, I can't. That's because when we drew it, when we clicked for the center point. While the YZ plane was highlighted, Solid Edge guessed that we wanted to create a relationship between the circle and the YZ plane. So now that circle is tied to the YZ plane. So if we actually wanted to change that circle and move it away from it, I just press the Alt key, click on the center of the circle, and now I can drag it away from that plane. As well as kind of inferred relationships while you're sketching, you can also manually create them. So I actually did want that relationship because it just keeps things a little bit tidier. So we have the connect command here. I can click on that. If I go back to the circle, hover over it, go over the center. Now we see this little circle with the center mark in it, icon beside my cursor, and that just indicates if I click now, I will select the center of the circle. So that's what I want to do. So I click. If I go back over to this plane, and now you see the line that was showing in the view when we were looking at it at 90 degrees. So I go back to that plane, and if I click there, that circle gets related to that plane. And we want to do the same with this circle. So I hover over the center for my little icon with the center mark to appear. Click there, again, go to the plane, click on it, and that relationship gets created. So now if we look at those circles, we see the little X here showing that's coincident, it's called coincident relationship. And now if I was to drag on either of those circles, they can't drag left or right. You can only drag up and down. Okay, so click on the circle, then the center. Yeah, so it will go up and down, but not left and right. We also want a rectangle by center. So if I click on that, and if I click on this is the origin of the coordinate system. So this is 0. This is, if I was to type in the coordinates, it'd be 0x, 0y, 0z. You don't really need to know that, but I just click on that. And now that's the center of this rectangle is always going to be in line with these two circles. So that relationship has been inferred. So now we have three shapes. We have a circle, which is 25.75, a circle that is 31.3, and this shape here, which is 20.73 by 10.17 millimeters. So even though we typed in the actual exact dimensions we wanted for this circle, this isn't really locked in, so I can click on this point of the circle and I'm able to drag out to a bigger diameter. I can also click and enter it in this box here. So if I wanted to modify this diameter, I would click on Smart Dimension, click the circle, and if I type in 25.75 and press enter, you'll see we get a red dimension. So that means that's a driving dimension. That dimension changes the diameter of this circle. So now if I click on this circle, and if I try to drag this point, all I can do at this point is move it up and down. You can no longer change the diameter. If I wanted to change the diameter, I could click on the dimension value and type in a new value here. Let the dimension drive the size of the circle. It's a driving dimension. Okay, and we can do the same for this circle down here. I click on the Smart Dimension, click on the circle, and the diameter of this one we want to be 23.25 millimeters. I press enter, and now we've set that as well. I'm going to choose a value of 16 millimeters for this and 20 millimeters here. And you can see now something has changed. We have a blue circle, a black rectangle, and a blue circle. If you've been following along and your rectangle hasn't changed color, you can check that the relationship colors option is turned on. This rectangle is black because it is fully constrained. It's fully defined by the software. There's nothing that Solid Edge doesn't know to define it. So you can see this line here has a little plus in the middle, and you can see a little red square at each end. So the plus means it's vertically constrained or horizontally constrained. In this case, both. The midpoint is constrained relative to the origin, and it's also vertical, so both ends are kind of vertical. And then the square at each end means that the points are connected. This line is connected to this line, and you can see all four lines are connected together, and all four lines are horizontally and vertically constrained. Whereas these circles are almost fully constrained. We have the diameter. We know that horizontally they can't move, they can only move vertically. So all we really need to do at this stage is to vertically constrain them, and then we'll have a fully constrained sketch. So let's look at the connect command. If I click on that, and if I click on the end of this line here, and if I want to connect it to this circle, because This rectangle is fully constrained. It can't move anywhere. So the circle gets pulled to that point when we click it. And the same here, if I want to connect this point to this circle, because this point is fully defined, the circle will move towards it. So now we have 3 black shapes, 2 circles and a rectangle in the middle. We could try to extrude this, but it could be a little bit confusing for the software. Let's just take a little look. I don't think it'll work. I'm just going to change our view. Oh, it does work. Okay, fair enough. Okay, so we're able to choose a direction, up or down, it doesn't really matter. Or we can also choose to go non-symmetric, which we can say we can go up 1 millimeter and down 2 millimeters from this plane that we've drawn it on. Or we can go symmetric, so we can go an equal amount either side of the plane. It doesn't really matter in this case, so I'm just going to leave it at symmetric and say 2.2 millimeter thickness. We see that pops up in the distance box here, and so we can kind of organically do it by dragging the mouse and clicking, or I can just press enter because the 2.2 is still selected and the cursor is blinking. If I press enter, it's locked in at 2.2. We can change the name of this feature, the Pathfinder, but it doesn't really matter. So I click finish, and now we have our part. Well, we have the basics of our part anyways. So I'm just pressing the middle mouse button and moving the cursor around to rotate my view. Now we can see our part. It's actually pretty good. We could do a couple of things just to make it a little bit better. Okay, so if I go back to home, so we can go to sketch, and we're going through the process again. So we can go create from a coincident plane. So we could select the top plane again, or in this case, we could select this face. So let me just turn off all of these base reference planes so they're not in the way. I can click on the top face of the part, and that's our new plane. And now again, it's gone into the line command. And now that we're in the sketch environment, and we have tools, and inside tools, we have this text profile command. So if I click on that, and we can choose fonts here, and I'm going to increase the smoothness. Okay, so we're just going to choose Arial. As the font, Arial Black, and I'm just going to type, so I'm just going to type €1, and I click, we can change the alignment to center, and I can click, I'm just going to change the style to bold, and click OK, and enter that here, and go through the same process again. This time we're going to enter €2. Oops, a daisy, so I need to change the font again. Okay, and I'm just going to enter that there, and go back to home. That all looks good, so I'm going to click this button to say the sketch is okay, and click finish. The first time we used the extrude command, we used the coincident plane option. That created this protrusion 1 feature shown on the Pathfinder. When we were creating protrusion 1, we were prompted to create a sketch, profile 1, which was nested within the protrusion 1 feature on the Pathfinder. This time we have created a sketch which is its own item on the Pathfinder. Now we're going to create an extrude. So instead of creating from coincident plane, we're going to select from sketch, and now it's looking for a sketch element. So I can click on this and I can click on this. So we have 2 items selected. And if I'm happy with that, I can click on this little tick. If I'm not happy, if I accidentally clicked on something I didn't want to, I can press the shift key and click on it again, and it gets deselected. But in this case, I do want both of those. And now I can click on this button here, and we can go to the extent step. So it has stayed on the same option as last time, which means it's trying to cut up and cut down at the same time symmetrically. Because there's no material above the top of the part, it's only really cutting down. We could also just select a one-sided extent, which makes more sense for this. And now you notice if I go up with the one-sided extent selected, it actually extrudes, it adds material. And if I go down, it cuts into the part, it removes material. So if we go all the way down, it cuts all the way through the part, but we don't really want to do that. So we can just go down 0.5 millimeters, press enter, and I'm going to press enter again, and it's cycling between these two. So what I can do is I can left click, and now it's kind of finished. It's just looking if I want to add a name. You can do this if the part gets very complicated, but we're kind of pretty much done here, so I don't think we really need to do it. So I click finish, and now it's asking for another extrude, which is good, but we don't need an extrude at this point, so I can just click cancel or X. All we really need to do now is a little bit of tidying up. So I'm going to add rounds to the part. We want a radius of 2 millimeters for the rounds. This value is already in the radius box from the last time the round command was used. So we can just select the edges we want to round. As we select each edge we want to round, it shows a preview of how the round feature will look on that edge with a blue highlight. If you accidentally select an edge, you can deselect it by holding down the Shift key while clicking on it. I've selected all the edges I want to round, so I can click on this check mark to accept the current selection set. I click on the preview button. We get an option to name this round feature. I'll just leave the default feature name and click Finish. Solid Edge automatically restarts the round command again, which can be useful if you want to round other edges on the part with a different radius. We don't really want to make another round at the moment, so instead I'm going to start the Chamfer command. We have different options for how to define the chamfer. We can use equal setback distances, a setback distance and an angle, or give 2 setback distances. Equal setback distances works fine most of the time, which would give us a chamfer of 45 degrees, which is a nice angle for 3D printing on most printers. The selection type has the chain option selected by default. This sounds good. We're going to use a setback distance of 1 millimeter. And now, if I hover over the edge to apply the chamfer, you can see it's not just selecting a single circle or a single line because we have the chain option selected. It selects the whole outline. So I can click to select the highlighted outline to apply the chamfer to it, click the check mark to accept the set of edges I have selected, and I can click Finish. Solid Edge automatically restarts the chamfer command, so I can actually do the same thing on the other side of the part. We can leave the selection type at chain and the setback at 1 millimeter. And if I select the outline of the other side of the part, click the check mark to accept the current selection set, and I can click Finish. And now if we look at the part, we might be kind of thinking, oh, that was a mistake. That chamfer looked a little bit too severe and it's kind of affecting the functionality of my part. Actually, the chamfer value we wanted was 0.5 millimeter. So I can select the feature on the Pathfinder, select Edit Definition, and we see the name here. I can expand, select Edge, and we have Edge Set, Setback. So all of these options are available to change. So setback is selected. I'm just going to delete 1 millimeter and type in 0.5. I could press Enter or tick this box and click Finish. That looks better. And for chamfer 2, same again. So I click on that, click Edit Definition. I'm going to click Select Edge to expand out this set. Setback is highlighted, so I don't even need to delete it. I can press 0.5, tick this little box, and Finish. And now we have our part. So now we can save that part in my design folder. I'm going to give it a document number and a title and a revision ID and hit save. So that file is now saved and I can go back to it and edit it in the ordered environment anytime I want. In the next video, we're going to reuse this part to create a $, trolley token. Yeah, that's it. I hope you followed along and I hope you have your own trolley token now. Thank you.